This is your Minecraft server, and this is your Minecraft server with Copenheimer, which as you can see isn't doing particularly well. Copenheimer, as you may or may not know, is a bot that tracks down completely private Minecraft servers and was created by 2b2t griefing group, The Fifth Column, and widely publicized by 2b2t YouTuber FitMC. The bot is used to find vulnerable Minecraft servers. Today, I'll be not only explaining how it works, but building a version of it myself, while also explaining the core concepts behind it, why it's so dangerous, and teaching you how to protect yourself from Minecraft's biggest exploit. Of course, just a fair reminder to not burn down random Minecraft servers, cause it's not a particularly nice thing to do. First, we need to ask the question, how does Copenheimer work? In order to start talking about how Copenheimer functions, we'll want to take a deeper look into another very functionally similar tool called massscan. It's a CLI, aka command line interface application that is used to, as the name implies, mass scan. It works by scanning through the internet, and quite literally so, as it scans through IP addresses one by one. IP addresses, for those who live under a rock, are basically the equivalents of addresses, but on the internet. Although, of course, as I'd like many to know, they don't actually give access to your address. This type of scanning is possible due to how IP addresses, similar to real addresses, use numbers, and, contrary to real addresses, only use numbers. For example, 127.0.0.1, which represents localhost, are just four 8-bit numbers which can be easily iterated over in the typical counting fashion. You might now question how massscan deals with so many requests, all at the same time, as the time for a request to return can oftentimes take hundreds of milliseconds, which would drastically slow down the speed of the application. Massscan bypasses this through the use of something called asynchronous tasks. Basically, what they allow for is for the computer to run tasks asynchronously, which allows for the computer to pause tasks or run them at the same time as others, which is great when dealing with stuff like, for example, packets. What massscan does is it spam pings tons of IP addresses and doesn't wait for a response in the typical synchronous fashion, where you wait before doing the next thing, but rather in an asynchronous fashion, where the result of the exchange of packets is stored in a buffer somewhere to be gathered later, allowing for a drastic speed up compared to the synchronous approach. Copenheimer basically does the same thing as massscan, and perhaps even utilizes massscan itself, although we can't confirm that due to it being closed source, but in a more Minecraft-oriented and easy to interface with way, with the only major difference being, of course, that Copenheimer logs whether or not the packets that were sent back were Minecraft packets, which is how it tracks down completely private Minecraft servers. Of course, your first response to this might be that, due to the sheer number of internet-capable devices, that it'd be impossible to get to your server, probabilistically, quote-unquote, as you'd be protected by some sort of smart toilet herd immunity. But that isn't the case. In fact, massscan can scan the entire internet in under 5 minutes with just a 10 gigabit link. Even if we assume that for some reason the people that practically worship griefing over at the Fifth Column for some reason didn't have a 10 gigabit connection lying around somewhere, and that they didn't bother to buy one, from what we've seen, massscan is more than fast enough for them to find your server anyways and do major damage to it. Not to mention that all the other groups that have access to applications similar to Copenheimer could do the exact same. Not to mention the fact that botnets are a thing. In order to delve deeper, we'll be taking a look at a version of Copenheimer that I custom wrote in Python.
So here's the code. As you can see here, we're importing MC status and more specifically the Java server component. This is because we actually have to interface with the Minecraft server and receive the packet back, make sure it's valid, all of that stuff in order to actually add it to our output file. For this example, we're using output.txt. We import multi-threading through the threading library, and we add asynchronous tasks through the async.io library. And what these help us to do is basically threading will manage doing multiple stuff at once. Async.io will manage stuff that we need to wait for. And that's the main difference that you'll find when dealing with multi-threading and asynchronous functions. Now, your question might be, if mass_scan can scan the entire internet in under 5 minutes, then why, when creating something similar, are we only scanning one port? Shouldn't we be scanning all of them just in case? Not to mention how most servers probably won't be on anything else other than the default port. We'll also have to mention how multiple ports, considering that there are that many, mass_scan can technically scan over the entire internet as stated before, just not over every single port, at least not under 5 minutes. We got the default timeout, the wait for timeout, and the IP iterations. Each IP iteration contains multiple threads, each thread scanning over an IP range, and each IP range containing two IP addresses, the start and the end. And by scanning over multiple ranges at the same time using multi-threading, we're basically able to do that a lot quicker. And your question might be, why are we having multiple IP iterations instead of just having really large IP ranges or using a ton of threads at once? First of all, threads are limited. At a certain point, the CPU and computer are just going to start basically emulating threads, which is going to be a lot less efficient compared to just using the correct amount of threads. And second of all, as mentioned previously, this stuff uses buffers which are limited and which we need to conserve, especially when looping over this many IP addresses. And we got the get address function because a lot of libraries, MC status included, expect a string for the IP address, so we'll have to parse from our custom IP address format to the string format in order for them to be able to parse it. Here we spawn the actual threads and then we join them to the main thread in order to wait for them to finish execution. And here's the actual thread, the actual meat of the code. So basically what we do, we initialize it and we create a tasks list. Now we loop from the start to the end. Of course, we have to add to the start in order to eventually get to the end. And basically we just take the Java server library and we look up the server and we just append that to the tasks. At the end of all of that, once you're done looping all over all of the IP addresses, for each task we wait for whether or not it generates an exception or if it doesn't. Because MC status for some reason generates an exception if the server doesn't actually exist. And then if it doesn't, we simply append the IP address to the output text file and we can just read that later for any Minecraft servers that we might or might not want to visit or sort or anything of that sort, and then we simply print thread finish. By doing all of this, we have created what's in essence a mini version of Copenheimer, and the fact that it's this simple, only involving 65 lines of code, really just goes to show how dangerous Copenheimer and just its concept is as something that we'll have to keep in mind for as long as Copenheimer exists, which is probably going to be a pretty long time. Now, of course, you might mention that, oh, these use dots. That looks like the IPv4 internet system. And again, it so basically MC status can scan over the entire internet, but when I said internet, I meant IPv4 internet. Another thing that mass_scan can't exactly do is scan over the entirety of the IPv6 internet. You could scan over a bunch of it, sure, but you're better off scanning over the IPv4 internet, since more Minecraft servers are going to be on there, not to mention the fact that there will be less empty space, and not to mention the fact that you'll be able to scan the entire thing, or at least most of it, assuming that you don't have a 10 gigabit connection or a connection that's fast enough to scan the entire internet at that speed. So what many of you guys might want to try to do is to find out how to use this. whether it be to learn about it, to add on to it, or for more nefarious purposes. That's just how open source software goes sometimes. So here's how to use it. So first of all, we need to input an IP range into an IP iteration inside the IP iterations list. So what we'll do for this example is we'll base it around another IP, since hosts oftentimes put the IPs for their servers really close to one another, which means that you can find more IPs in a more concentrated amount. So we're going to be using this kubecraft proxy IP. You can get these IPs by just pinging the domain with command prompt. And here's the range we're going to use. As you can see, this includes this IP. So in order to prove that it worked successfully, you're going to see this IP within the output.txt, which as you can see right now is empty. Something else I recommend is to run this with PyPy because it's a lot faster, which makes it a lot nicer to run since PyPy is JIT compiled. So, although regular Python will of course also work. So you can either get command prompt or you can just, if you have Python installed, you can just double click on the Python file as long as the Python version is recent enough. So PyPy Copenheimer .py. Also, just a reminder, you can install all the needed packages from requirements.txt. If you don't know how to do that, just search that on Google. So pypycopenheimer.py, and let's open output.txt and see what it returns with. As you can see, it's looping over it. And we got all the IPs, including the IP to the kubecraft proxy that we based the range on. So this is how to use Easy Copenheimer.
Now that we know more about Copenheimer, it's time to discuss some methods for preventing griefers with access to Copenheimer or clones of it from gaining access to and nuking your server. One method is based on a weakness of Copenheimer and scanners like it, which is the fact that it won't be able to scan over every single port. Since Minecraft supports the use of different ports by adding the port number after a colon, we can simply switch our server's port. Another way is to switch to IPv6 addresses only, since scanners like Copenheimer will mostly be reserved to just IPv4 addresses. Other than that, there's of course a reminder to always keep backups and keep a whitelist if possible, which you should be doing regardless of whether or not Copenheimer's a thing.
Also, the GitHub issue, it's real. You can check it out on the GitHub. It's from the official orsondmc account. Listen, previews.
This is the first video on the Random Gaming Dev channel. If you like this sort of content, please like and or subscribe because I hope to get a lot more of this sort of content out onto YouTube.